These formulas are not as scary as they appear to be, so just be aware of that. So we're gonna find sums of geometric series. So a sum would be adding them all up. So if you had a sequence, it would be adding all the numbers up. There are formulas for that because you might be adding up 20 numbers total and you might not know what those numbers are. So there is a shorter aspect to this. So a series is the sum of the terms of a sequence. The sum of the first n terms of a series is determined Sn. So if you see the capital S, that means the sum. All right. The geometric series is the sum of the terms of the geometric series. Now the formula we're going to be using the most is this first one. If you're given A1, R, and N, that's what you're going to deal with in the notes today. I will tell you in your homework, you might have that on 1 or 2 problems. It's applied similarly. You just have A1, R, and AN. So it'll be labeled for you. Okay. But just plug them in, but we are largely going to be using this top one up here. Okay. And the top one primarily will be on your quiz. I will provide you all the formulas, you just need to know what it's used for. Okay. So, A1 minus A1 times R to the N over 1 minus R. But the other one you might use on your homework on 1 or 2 of them. Okay. Now this notation down here, we're not going to deal with at the end. It is basically giving you all the information just in what's called sigma notation. Okay, and the sigma notation is like shorthand. It uses the Greek uppercase letter S. So that's this right here. Okay. You probably know other Greek letters. Delta is the triangle. Okay, but sigma is kind of weird looking thing, but that means sum because it's the Greek letter S. Now there's a lot of information up here, so I'm not going to go in super depth right now. We'll talk more about it when there's actual numbers in there on the back. But the number on the bottom, that is the term of the sequence that you're starting at. So this one would be the first term. The top one is where you're stopping. Now we're going to be mostly dealing with finite series, meaning that they stop at some point. There are some infinite ones which don't stop. Those are applied differently. We're going to do finite ones. If you're taking pre-calc next year, you will see sigma notation again. Okay. But it's just a shorthand of listing out all the information. Okay, so I'll show you how to interpret that on the back. It's easier to look at with numbers anyway. Okay. So starting off with, if you don't see sigma notation, you're not using it. Okay, you're going straight to use the other formula. Okay. So Kate wants to set up some dominoes so she can knock over 1, which knocks over 2 more, each of which knocks over 2 more, and so on. If she wants to make 6 rows of dominoes, how many will she need in total? So this is asking you to add up all the dominoes without actually knowing the sequence. Okay. Now, how many dominoes are in the first row? 1. That's what she's starting with. Okay. So that is our first term that would be in our sequence. Okay. So your A1 in this scenario would be 1 because there's 1 domino in the first row. So if you want to make a note to yourself on where this is coming from, in the first row. Okay. So 1 domino in the first row. Okay. R from yesterday is how many times it's being multiplied as we move through. So what value is that? 2, because it's knocking over 2 more each time. Okay, so 2, so each time it knocks over. The only other value you need is n, which would be number of terms, in this case, number of rows. 6. Okay, I want 6 rows. All right. A lot of times this information will just tell you what it is, but you need to know how to pull it out of a problem also. Now we're going to use that formula that's at the top of your paper. I'm just going to rewrite it here so that we have it. So we have A1, we have R, we have N. So we have everything. So we need to plug it in the formula. Then the calculator will do basically the rest of it. Okay, but take the time to plug it in appropriately. So we're finding the sum. If you wanted to put sum of 6, you could do that, but I'm not going to be picky. A1 gets plugged in twice. So 1 minus 1 times 2 to the 6th power over 1 minus 2. So I just put everything in its spot. Now I'm going to let the calculator do the rest of it. Okay, we're going to simplify the numerator down. All right. within the calculator. So enter it in exactly as I wrote it. 1 minus 1 times 2 to the 6th power, just like that. Okay. What does that come out to? Negative 63. That's the numerator. What is the denominator? 1 minus 2 would be a negative 1. So what's negative 63 divided by negative 1? 63. So if she wanted to make that scenario happen, she would need 63 dominoes. Okay. Not too bad. That one was pretty easy. Okay. All right. Now, admittedly, this next one, I gave you decimals and fractions in the same problem because that's not going to happen very often. So if you can handle one like that, the answer comes out nicely, believe it or not. But sometimes decimals and fractions are involved. So it should make the one we just did seem incredibly simple. Okay. This time we don't have A1. Okay, so that's what we're solving for. We do have the sum, we have N and we have R. So we're gonna have to solve for A1 this time. Okay. So that same formula, I'm just gonna rewrite it again. So we have it. Now, most common mistake I've seen is this A1 just disappears, so make sure that there are 2 in this form. The only time there isn't is in that second form of the formula that's still in that chart on the top of the first page. All right, that is AN, so that's different. Okay, so on the S side would be 21.3125. Now we're gonna do a couple steps, so don't write too big. I'm gonna try not to write too big. A1 minus A1 times 1/2 power of 5 over 1 minus 1/2. I'm gonna zoom in a little bit so that's not so far away. Questions so far? Now, stay organized, especially with fractions and decimals. It's not as bad as it looks, but if you lose something, be careful. So this side's gonna stay the same temporarily, right? What's the denominator gonna become? 1/2. Okay. If you wanted to do 0.5, you really could. It's totally up to you at that point. Okay. Now, what is 1/2 to the 5th power? What's 2 to the 5th power? 32, so it's 1 over 32. Okay. So we have A1 minus A1 times 1 over 32. Okay. So 1/2 to the 5th power is 1 over 32. So it'd be 1 to the 5th over 2 to the 5th. All right. Now here, sometimes some people last are gonna a little confused. So if you wanted to rewrite this, you could put the 132 in front of the A1 it's attached to. Reason being, so I'm gonna do that. You don't have to do that. So if you want to do a swatch, you can do that. So I'm just rearranging. So I have 132, A1. So if you wanted to flip those, you could, because we're used to seeing numbers in front of variables anyway. Now these are generally like terms, and there is definitely a 1 here. Okay. So if we had a 1x minus a 2x, what would that be? It would be negative 1x. So you can still subtract these as if they are variables. So 1 minus 1/32. You could totally do it in a calculator. What do you think about it? 1 would be like a whole pizza. If it had 32 slices and I took 1 out, how many are left? 31. Alright, so 1, which would be like 32 over 32, minus 1, would be 31 over 32, A1. So you treat these like variables, whether the 1/32 is in front of the A or not. Okay, so it's up to you if you want to rewrite it that way. Okay. Alright, now it's still over 1/2. So from here you have 2 options. I'm going to tell you what I would recommend to you. Okay, I would not move stuff to the left. You can actually divide 31 over 32 by 1/2. I would do it in the calculator because that makes less room for error. Put it in parentheses. So So I prefer everyone do it with me. 31 divided by 32, close your parentheses, divided by 1/2. Which you could do 0.5 if you want to, or you can do 1 divided by 2. Okay. So it will divide the fractions for you, put it back in fraction form, which would be what? 31 over 16. Okay. So 31 over 32 divided by 1/2 is 31 over 16. We're almost done. So now how to get the A by itself? Good. It's multiplied by the reciprocal. So 16 over 31, because that will remove the 31s and the 16th. So within our calculator, okay, 16 divided by 31 times 21.3125, believe it or not, is a whole number. 11. Technically, as long as you're not rounding anything. So you would only round at the very, very end. So if you do leave stuff in decimal form, technically that's okay. Just don't round it. Okay. Either way, the answer needs to be 11 on that one. Okay. Now, most of what you'll be doing in this case is either just fractions or just decimals, not generally both. But now you have an example to go off of if you did have both. Any questions on that? Okay. Now getting into sigma notation down here. Again, it's just a way of giving you all the information the last two gave you without you having to list it out. Okay. So, a few things that we need. We're still using that same formula because we're finding the sum. So we need A1, we need R, and we need N. Now I'm going to tell you where to look for those. Okay. And they're in the same locations every time. Now there's other letters in here. You'll notice they use K. Sometimes it's J, sometimes it's M. It's different letters all the time. It doesn't matter. Okay. This is actually similar to the form that we were doing yesterday. Okay, with the explicit form, but it's important to pay attention to the number on the bottom underneath the sigma sign, which is 5. Okay. So normally A1 is the first term, which would mean K equals 1, but this time the first term we're starting with the 5th term. It's not always that way. Okay. But to find your first term, you take the K value and plug it into the exponent and simplify that down. That would be your first term that you're dealing with. Okay. So to find A1, you plug the K value on the bottom into the exponent and simplify. So 3 times -2 to the 5 minus 1 power, which is 4. So within our calculator, again, 3 times -2 to the 4th power. So 48 is your A1 term. So if you want to make a note to yourself, to find A1, you plug the bottom number into the exponent and simplify. Okay. Any questions about that? Now R is the base of the exponential part of it, which is in the parentheses. So R is always going to be right there, -2. Okay. So it's whatever the base of the exponential portion of it is. Now N on example 1 was 6 because we had 6 rows of dominoes. Okay. N is how many numbers in this sequence? Now that is 5 through 12, including 5. So 5, 6, 7, 8, 9, 10, 11, 12. That's how many numbers? It is 8 of them. Okay. 5, 6, 7, 8, 9, 10, 11, 12. 8. A lot of people make the mistake of doing, well, 12 minus 5 is 7, so that's 7. But the 5 is included. Okay. So it is 8 terms. There's a trick to that works every time. So if you think you might make that mistake, you do the top number minus the bottom number and add 1 back in. Okay. So to find N, you do 12 minus 5 plus 1. So if you always add 1 back, it includes that number. Okay? Because you might have like 100 to 36, so you might need to do some subtracting because you probably won't count on your fingers that high. A lot of times it's just 1 through 12 or something like that. Okay. But it's 8 because it is 5, 6, 7, all the way through 12. So is everybody clear on that part? Okay, so now we have A1, we have R, and we have N, so we're going to use that formula again, just like we did in the very first one. So our sum would be 48 minus 48 times negative 2 to the 8th power over 1 minus negative 2. Now the top again, we're just going to do in the calculator. We're going to let it be. So 48 minus 48 times negative 2, make sure it's in parentheses, to the 8th power. Negative 12,240. What's the denominator? 3. Because 1 minus negative 2 would be a double. So negative 12,240 divided by 3. Negative 4,080. Now a sum can be negative because that means there's negative numbers in the sequence. And that's because the R value is negative 2. So it's times negative 2 times negative 2 times negative 2 times negative 2. So it will switch the signs. So the sums can be negative. Any questions on that one? Now the last one's pretty similar, just involves some decimals. So if you want to work ahead a little bit, just be careful. At least set up the problem and maybe stop there. Okay. But it's in the same locations. All right. So again, we need A1, we need R, and we need N. How do you figure out A1? So plug whatever the K value is, it might be another letter, but whatever the number is on the bottom, plug into the exponent and simplify. So 23 times 2.5 to the power of 2 minus 1, which is just the first power. So basically 23 times 2.5, what is that? It is 57.5. Okay, so if you see that? If you want to do the first power, it's not going to hurt anything. So 57.5. What's R? 2.5. It's the base of where the exponent's attached to. And how many terms are 2 through 6? 5. Okay, including 2. All right, again, the trick for that, top number minus the bottom number plus 1. So it adds the 1 back. So that'd be 4 plus 1, which is 5. Is that trick helpful to some of you? Okay. So just one more than the difference. All right, so plugging in to that formula, I'm not going to rewrite the formula this time. 57.5 minus 57.5 times 2.5 to the 5th power, all over 1 minus 2.5. Now, this one is going to come out to a decimal, and it does tell you to round to the nearest tenth, but you should not round till the very, very end. Okay. So if you notice your numerator is going to involve decimals, which this one, it's got 3 of them up there, and you have a power involved. Do you guys remember when we did the big log things and we put in the brackets and entered the whole thing into the calculator? You can do that with these. So you can put brackets around the whole numerator here and the whole denominator, and it'll do it all at once. And we could have done it on the previous ones, but those came out to nice numbers anyway. But you could do that. So I'm going to do that on this one, just to do it all at once, because you don't want to round to the end. So open bracket, 57.5 minus 57.5, parentheses, 2.5, close parentheses, to the 5th power, and then close off the bracket. So that's the whole numerator. Divided by, open bracket, 1 minus 2.5. So you don't have to do any thinking. It will do it all for you, but you need to tell it what it's doing. Okay. And we get what to the nearest tenth? 3705.2. So it will tell you where to round. Generally in this section, I think it's the 10th. but do not round anything till the end. Okay, so if you do it separately, you can do the whole numerator, leave that result in the calculator, and divide it by the 1 minus 2.5. Again, in your homework, you may, I know on at least one of them, you may have to use the second formula, so just be careful when you do so. Okay. So it's a1 minus an times r, no exponent. Okay. I know it's at least one of them in your homework. I don't remember exactly which number. That's only 10 problems. It's in the same textbook area as the previous assignment, just one page after. So 30 through 37 and 54 and 56. So it's only 10. You can probably get most of it done, if not at least a few.